Hey, warm welcome to the second episode of BSc Se Kya Hoga Science Unlocked podcast series. And this is a part of the Monday Morning Learning podcast series. Extremely happy and grateful to Dr. Sai Santosh Kumar Raavi for accepting to be our second guest. Dr.
Thank you.
Santosh, warm welcome to you. Any warm welcome words you have before we go for a round of introduction and the questions?
Yeah, at the outset, good morning to all, and thank you, Ravikant, for this invitation. Uh, I look forward for this, and let's see how it goes. I like the concept of BSc se kya hoga because right now, given the present, various aspects of JEE, NEET, all these things. And then a lot of competition. It's a good series to have so that parents can see the other aspects of it. Yeah. This is something which I really appreciate the initiative.
Thank you. Thank you, Santosh. Quick round of introduction to the audience about Dr. Sai Santosh. He's currently the professor of physics at IIT Hyderabad since 2014 and has been professor since October 2023. In terms of education, he's done MSc Physics, Photonics at Sri Sathya Institute of High Learning. He's done his PhD at the University of Hyderabad between 2004 2009. His research areas are into ultra-fast spectroscopy, perovskites, organic semiconductors, optoelectronics, nonlinear optics, single photon emitters, photodetectors, scintillators. Is done global stints in Italy, Brazil, Singapore, and Japan. He's got a lot of fellowships, JSPS, BASE, FAPESP in Brazil, FRSC, FTAs, and lots of them. And in terms of his editorial roles, he's been the associate editor at Optical Materials and Optical Material X Elsevier, and also part of the editorial advisory board, APL Engineering Physics, which is AIP. In terms of the awards, he's got the Faculty Research Excellence Award 2024 from IIT Hyderabad, Young Scientist Award in Physics, OSA Senior Member since 2020. That's in short about Dr. Santosh. Uh, I'm going to definitely mispronounce some of these research areas, Santosh, so please bear with me and correct me wherever I actually go wrong. As you rightly said, as a parent, because I've got child who's just done his 12th standard, and we were exploring, pure sciences, engineering, and a lot of other options for him. And that's how the origin of BSc Se Kya Hoga actually came, because we ourselves were asking, if you don't do engineering, BSc se kya hoga? And when he got a seat at Parthi, that's where speaking to Anil Kumar sir and my batchmate Ravi, who's the associate professor there at Parthi, TRC, those were batchmate, Sai Subramaniam, my batchmate. Three of my batchmates actually gone through the MSc chemistry route, went on to do bridge courses, one at University of Hyderabad, one at IIC, one at IIT Delhi, and moved on to their postdoc. So that gave a lot of clarity in terms of and confidence that BSc say really much can actually happen. So that's the underlying factor as to why we came up with the series. Let's start off with the questions. Santosh, I've got 18 questions. I don't know whether we'll be able to fit everything in this
Sure,
episode.
sure, 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 sure,
But we'll
sure,
try.
sure,
Yeah.
sure.
So we'll start with the first one, the origin story, the student who chose physics. The first one is you did your MSc in physics with a specialization in photonics at
Yes.
Stanford High Learning, then your PhD at University of Hyderabad. Can you take us back to that 17-year-old who chose physics? What did your family think? And was there any moment where someone asked you, physics se kya?
Yes, yes. Actually, it's yeah. When I look back, give me a few seconds. So it's like this. It's been quite a journey, and yes, it starts from there. And yeah, the point is this. Let me quickly go back to my intermediate, where I did in corporate college. Okay, I don't want to name it. Probably can see, but yeah, the point is this. In our college, what was the goal? Was either you must be an IIT or a MSET, if not BITS. Okay, so these three were the major goals, and this is how the training was there. You know, the kind of rigor we used to have, right from getting up in the morning at 4:30 and daily study hours, morning languages, afternoon the mainstream MPC, and then every evening we had an exam.
Yeah.
So almost every week, every 2 weeks there was a grand test,
Mm.
And every evening there was an exam to write on these exams. The point is, yes, I lost, any fear of exams. But the point is this. My watershed moment was, we just were in our second year of intermediate, and we saw that the entire corridor in one of the buildings in the college was converted into an engineering. Now, in these corridors, there were classrooms in which I studied in my first year.
Mm.
And then I realized that, yeah, that's the time I'm talking about, before 2000, right? The beginning of this dot-com boom, whatever you're talking about it.
Yeah.
So that was the time when engineering is catching up and a lot of interest in IT boom was going on. It's not yet started. I mean, it's not peaked. It
Yeah.
was on the rise.
Mm.
And I sort of felt that given the boom right now, and if I look at the way I did it in Andhra Pradesh, undivided Andhra Pradesh. So given the number of engineering colleges coming up, and I was a bit afraid of where I would be
Mm.
as an engineer. The point is, I wasn't really great at, skillful at making things.
Mm.
So for me, I had the concept of engineer, someone who actually develops and, do engineering aspects of it, create some kind of, an instrument, machine. This is what the kind of thoughts I had as a school going kid, right? I never thought about it. And the only thought which I sort of had recurring to me is that, yes, I'm good at theory. Probably I should stick to the theory. But then, with all these thoughts, I'm still confused. And as you have said personally, parents were also confused where to go. And yes, luckily for us, we always had one reference point, that is Puttaparthi. And it so happened that, let me just quickly go to a personal experience. After my intermediate first year, I got little less than what is expected.
Mm.
Okay, so the percentage was 93 point something. And everyone was thinking we should get above 95.
Mm.
So because I didn't get 95, I got 1% less than the expectation. I was very depressed. And I just went to Puttaparthi after the results.
Mm.
And then sitting there, I got my Padnamaskar and all these things. And then I thought, I think it's enough. That particular watershed moment was enough for me to really change my direction. And yes, I did very well in my second year intermediate. I got seat in BITS Pilani. I got a good MSET rank, but still, I cleared the exam and got into BSc. And from there was no second thought when it comes to the physics, because moment I thought I will do PhD, BSc, I always thought I will do physics.
Right.
The reason is very simple. I used to enjoy physics. I used to see physics everywhere. Somehow it just, and luckily for me, because I was never really pushing myself to get good MSET rank or IIT exam, or in fact, I didn't write IIT exam. Is that if you're really into the deep coaching, teachers do say that, physics is not scoring. Concentrate on chemistry or math. This is what the teachers used to say that earlier. So I never got into that kind of mode where my teachers told me that, physics is difficult. So I used to enjoy the physics the way it is supposed to be, solve the problems. Where this Resnick held a textbook, we used to solve it.
Yeah.
And that's how I started liking the physics, and I got into BSc. And my BSc is purely my own conscious decision to get into it. It is not that I didn't get an engineering seat.
Yeah.
I really wanted to do BSc and in BSc physics.
Absolutely, Santosh. Very lovely to hear that. A couple of thoughts actually popped up once you started explaining. Any kind of traits which you can actually describe to the parents and students that, once they actually start enjoying, just as an example, any kind of pure sciences, either physics, maths, or chemistry, how can they actually decide to go for a learning path in pure sciences? Any kind of trait in this kind of?
Yes. When it comes to the trait, it is very difficult because in India, unfortunately, our judgment of someone being good is with the marks.
Right.
Okay, that's the yardstick people follow. It's always the yardstick of how good this guy is when it comes to the marks. Is he getting 95% or 100%?
Yeah.
I remember one of our teachers used to say that he got 1 mark less than other 2 subjects in his intermediate, and he chose that subject as the main topic. I think it's one of the chemistry lecturers. Yeah, I remember that. So, he got less in chemistry, so he chose chemistry. The point is this. Our yardsticks are slightly off compared to the way either in Japan or West, people think about it.
Sure.
So when it comes to the traits, I think it's very difficult to judge as a parent.
Mm.
However, what I personally feel now that I've been here in this ecosystem, if the student feels that they can do better following pure sciences, they should do that.
Right.
Okay, because the peer pressure is always there, and luckily for me, my parents never told me to change my thought.
Right.
I mean, other than my parents, I always thank my parents for letting me think the way I'm supposed to do. I'm doing it.
Mm.
Everyone else were having a lot of second thoughts
Right.
when I got into BSc, and it was as if uh, multiple thoughts came in multiple directions. So many people said, "Okay, we are ready to fund you." In
Mm.
fact, our own college principal, my intermediate college principal, was not happy when my father went to take the TC, saying that you are spoiling your son's career by letting him do. So my father only said, he wanted to do it, he did it. I respect his decision. So I think I thank them for that.
Mm.
And I'm again, what we are because of our own parents. So
Mm.
they never pushed me, and that sort of guided me all the time. And yeah,
Sure.
they were there for me. But the point is this: is what I always feel, that as a parent, if the kid feels that they can do better in that direction,
Mm.
they should be able to give that chance. Other than forcing them, because right now any student who is good, little better
Mm.
in class 8, they're automatically put in a coaching center.
Yes.
Okay, so this is the trend right now, and more or less, sometimes the student is interested, sometimes the student is not interested, parents are interested. More than everything, it's a peer pressure. Everyone else is doing, I also do it, which is not necessarily a bad thing, but one can, it's okay. Go to a good school, get coaching or whatever, learn everything, no problem.
Mm.
Become good in the subject. But eventually, when you realize that, maybe my calling is there, I think that kind of freedom student should be able to get from his parents, from his right parents. So that's the thing which I felt. And when it comes to the traits,
Mm.
Naturally, each of us will have an inclination towards a certain subject.
Right.
Okay, be it math, physics, or chemistry.
Mm.
It's not that, I think a good student would be able to do everything because they are the basic foundations for anything we do for that. Just because now I'm doing physics doesn't mean that I should forget all the things I learned it in intermediate maths or 10th maths. So the mathematics, physics. So science and maths are important for any technology. Okay, be it in BSc or BTech or whatever you take, whatever we learn in class 10, everything what we do till class 10, to some extent, to a major extent of class 12, is all important for any branch, be it engineering or sciences. So I think from a good student should be able to do good things in everywhere. But then automatically enjoyment is there. I'm enjoying more. Okay, there are a lot of sweets, but sweets are all sugary based, right? But there are some sweets we like most. There is no specific reason why you like a sweet. You just like that. It's all sugar at the end. It's all sweet. So the variety is very, very personal. And I think parents should be able to judge. And now with so much of knowledge explosion, a lot of opportunities for the student, the student should also decide which is his or her calling.
Absolutely.
So this is what I think, because there's no specific trait which I can think of at that age. They're too young to do that.
Absolutely, Santosh. Thank you for that. So, moving on, you didn't just stay in India. I think within a few years of your PhD, you were doing postdocs in Milan, Sao Paulo, and Singapore, and later research fellowships at Princeton and in Japan. So, how did a physics degree from Hyderabad unlock doors in 4 continents? That's a question for you.
Okay. So, yeah. So the important aspect of any, so how does it work out? So, after masters, we do PhD, and typically earlier, now things are slightly changing, is that the career graph of any PhD is to get into academia. So it is like you do PhD, you should get experience after the PhD with which you apply for a academic position. Okay, so this is the route which all of us followed and we still follow. Now, there's a lot of other industry options, but let me get back to what we used to do those days, is that it is known that you finish PhD and you go abroad for a postdoc.
Yeah.
And this is the point where competition is important, your excellence is important, how well you do your PhD is important. So how do I get it? We just apply and we get somewhere. So there's either getting a postdoc is either with recommendation or some kind of references, or we just apply. So in my case, I applied and I also got a recommendation. So in a way, majority of us send emails. I know my senior who sent about 500 to 600 emails to various professors across the world to apply for positions, because it is not that anyone will take it. So the way postdocs happen is that the senior professor anywhere else in the world, wherever it is, be it in India, somehow even Indian professors are also giving the PhD postdoc positions, is that they get a project, they get a big fund, project fund, and with that project fund, they hire a postdoc. Okay, so we look for such professors, which we'll never know. So we keep writing, and if the profile matches, the requirement matches with our skill set, we get the opportunity. So this is how I went to Italy, the Politecnico di Milano. And the fun thing is, the project with which I went failed within 2 months.
Right.
Okay. So it failed, and the professor also was not sure what to do next. But somehow, we Indians are good at jugaad. So we did some jugaad. And sort of that helped me to take the next position, which is in Italian Institute of Technology, IIT, they say. And I continued to stay for 4 years in Milan. And then I got opportunity to work in Nanyang Technology University as a senior research fellow before I got the position in IIT Hyderabad. So it's like about almost 5 years of postdoc before I got this position in IIT Hyderabad. Now, once I get to Hyderabad, once you get to an academic position, that's the freedom which we get, academic freedom. So you can always use your summer the way you like it.
Right.
So with this thoughts, after 2 years, I started applying fellowships. So if you look at my career graph, there is always a fellowship every 2 years. So every alternate year, I try to write some fellowship, spend my summer outside. So initially I started with Brazil, with FAPES fellowship, it's University of Sao Paulo. After 2 years, it is 2017. In 19, I got this Bhaskara Advanced Solar Energy. It's called BASE Fellowship. It is under Indo-US Science and Technology Forum, where I got opportunity to work in Princeton University.
Excellent.
With in electrical engineering department. So that's again one more nice example that you need not be stuck with physics. So being a physics department, I worked in E department there on some solar cell kind of work. So that's how it is. And after that, 2 years COVID came. After 2 years, went to Japan on NIMS fellowship. So so it's like that. On summer, we always have opportunity to go abroad, and there is always funding to get it. So these fellowships provide the funding, the travel funding, accommodation, everything is taken care of. So you can just go and do your research. So that's how it is easy to travel.
I see so much of joy when you describe Santosh. I mean, similar experience I had when I was speaking to Anil Kumar sir. And I also speak to a lot of corporate leaders. So I've spoken to maybe around 70, 80. Not saying that they were sad as such, but the kind of excitement someone actually has going deeper into a subject that they love is very different the way they actually explain. I think something which I think students should definitely learn from you and from sir as well. Moving to the next theme in terms of the real work, the ultra-fast light, perovskites and next-gen tech. Your research actually sits at the intersection of ultra-fast spectroscopy, perovskites, organic semiconductors, and optoelectronics. Can you explain in the language a class 12 student can follow what problem you're actually trying to solve and why it matters for the world they're about to inherit?
Yes. Okay. So it's a long question, but let me break it.
Sure.
The last part is the optoelectronics. That's the key word, let me say, because the other things are very little technical. Optoelectronics is something which is much more simpler to understand from a school point of view, because that word is already introduced much earlier. So when you say optoelectronics, we are all aware of electronics. Okay, we are surrounded with electronics. Now, optoelectronics is there's a component of optics in it. So in general, optoelectronics deal with devices which sort of converts, it's sort of interaction between the field of optics and field of electronics. So light to matter, matter to light. So light, electronics. So devices where we use light to get some current out of it, or we use current to get some light out of it. And overall, we use this for transmission of data or some kind of information processing. So more or less, this is the general concept of an optoelectronic device. Okay, so this light is there and electronics, both are there. So now, where I come in, Again, this is very specific to what I do because that's my training of PhD. I worked in high energy, intense light matter interaction. So high energy light, laser matter interaction. So that brought me into this field of ultrafast spectroscopy. Now, what is ultrafast? It's like this. Now, when we blink, or I blink, when we blink, that blink corresponds to 1 second approximately. Now we talk about 10 to the power minus 15 of that second. It's very fast. Obviously, we can, our positional vision is still tens of milliseconds. Okay. We cannot feel below that. Okay. So that is the kind of time frame we are talking about it. Now, what is the femtosecond? Is ultra fast. If I roughly tell you, simple way of looking at it, we know speed of light. It is very fast, 3 to the power 8 meter per second. Okay, that's the kind of speed we are talking about it, which means that it is in 1 second, the light travel 3 into 10 to the power 8 meters, right? Now, if I look at the time light travels through the cross section of our human hair strand, okay, which is of roughly 100 microns. It's about 30 femtoseconds. Okay, so this is the kind of some mistake, but that's the kind of timing I'm talking about it, where light barely crosses a very short period of time, short length of time, a lot of length. So why this is important is that there are many processes which are very fast. Let me give one example of such a process. Our eye. How are we seeing it? We all know that in our eye there are retinal cells. Okay, so these retinal cells are responsible for our vision. This is something all of us know in just a general thing. Now, how fast are these molecules respond? So that is in the order of few femtoseconds.
Right.
Okay, so this is the time you're talking about where electrons are moving across. Okay, so we can literally track the motion of electrons. Okay, indirectly, not directly. You cannot see an electron, yes, of course, but yeah, you can literally track the flow of electrons at that time scales. Now, coming to the direction which I'm working with, you mentioned few materials like perovskites, transition metal diatomates. Let me put it in a much simpler ways. These are all organic semiconductors. We are all aware of semiconductors. There are 3 different varieties: insulator, semiconductor, and metals. These 3 are basic common things from a school perspective. The semiconductors are those where the band gap is there. So we're talking about materials which are exotic in nature, they're cheap, they can be made, and ultimately where we are looking at is how do we push the technology frontier further. Okay, what kind of technologies are we talking about it? Now, from a research perspective, yes, I'm working on this kind of spectroscopy. Okay, spectroscopy is another technical term. Let me not get into the details, but the point is we are looking at figuring out how the electrons are moving, how to track the electrons or the charges. Ultimately, when we look at a current is flow of electrons, which is charge. So how do I track charges? Then I try to combine that initial time scales to actual device, which is optoelectronics. Now, what are optoelectronic devices? As I said, anything to do with light and electronics, right? So simplest thing is a solar cell, which converts light to electricity. That is, you send in light, current comes out. Opposite, what is the next part of it? Let's say contrary to it is you send the light in, light comes out. That is the LED, light emitting diode. Okay, so the applications are different. But when I look at fundamental perspective, I have a device where if I send in light, I get the current out. If I send in current, I get the light out. Okay, now this process can be tracked. Okay, when the light is interacting or the current is interacting. So you can track those material properties in this fast time scales. So doing this, we can fundamentally understand or screen out which material is good, which material is not so good. And finally, as I said, it is not that we get to solve the entire problem. It's a part of the problem which we try to solve. So we try to provide knowledge to device people or some industry guys who are actually making these large scale devices to say that yes, certain systems are good, systems are not good. So eventually, these are the kind of inputs we provide with our research. That's the kind of frontier we are pushing in. Okay. Now, when it comes to the specific materials, let me slightly digress about the aspect of this perovskite. Now, these perovskites are very well known. It's been there for more than a century. People know about the systems. However, their applications in these optoelectronic devices sort of exploded from last 1 decade. Okay. So, where are the applications? Again, as I said, solar cells. What solar cells we all aware of? It is a silicon solar cell, which is there everywhere. The kind of gray big panels you see is silicon based. Okay, it has its own limitations, and people are trying to see how I can come out of the limitation. So perovskites have come out as an alternate material for it. Another aspect is from the solar cell perspective, there is always an interest in making flexible devices, wearable devices, right? So which we cannot do with silicon. Silicon flexibility is very poor. It will break. So these kind of materials can be used for flexible things. So it's just a solar cell perspective. The same thing can be extended to the LED perspective. Okay. So we can have flexible LEDs. Now, when it comes to the photodetector, which is another kind of direction I work with, photodetector is again light in, current out. It's similar to a solar cell. It's just that when it comes to solar cell, we try to convert the entire light from the sun to electricity. And it comes to photodetector, we try to detect a light pulse or light signal. So again, the concept is the same. As I said, fundamentally, it's the material which is actually responding to light or to electron input bias.
Yeah.
So we look from a fundamental perspective, and that is the point which I always get excited, because every material is new and every material gives me a surprise.
Yeah.
And that sort of pushes all of us every day. It's like, there is this famous word called ikigai in Japan. So it's something which we look forward every morning, that let's see what this material is telling us. So we sort of talk to these materials, these exotic optical materials, and we look for such knowledge which can help the industry.
Absolutely.
So that is the point which I would like to inform.
Sure.
From a very simple perspective. Yeah.
Absolutely. So one question which I had was, all of us are talking about AI tools, right from Claude to all which are available, right? So what's the kind of usage of AI tools in your own domain? What kind of tools are actually using? And there is kind of a perception that because of AI tools coming in and because they're so knowledgeable and they quickly pick up knowledge, pursuing pure sciences, does it really make sense? These are the two questions which I have.
Oh, yes. This is something which is very burning and very hot topic. Very hot topic because let us probably you belong to a generation where there was this telephones where you could ring it up, right?
Yeah.
Okay. And then you have seen through the transitions of that telephone to the mobile phones. And we all agree now that we forgot phone numbers.
Yeah.
Okay. Now, we come from so when we look at our own childhood and now, things have changed drastically, and things which are very natural is no more natural. We don't remember directions. We rely on Google Maps. We don't remember numbers. We rely on it's there. Now, when it comes to the security people, there's a lot of security protocols. Passwords are all saved. There's a digital locker, and we don't remember the passwords also.
Yeah.
Okay. So what happens is, over the period, we sort of use the technology. We have developed the technology to help us, and eventually we become slaves of our own technology.
Yeah.
Okay. So this is something which is scary to me, because we know what it is to remember a phone number, right? Because we have seen the life where at some point of time, there is one or two numbers which we need to keep in memory, which is life-saving for us. But the new generation, they would not understand what it is, what is the concept of remembering a phone number.
Yeah.
Okay. When it comes to going to some place, unknown place, you and I can quickly go and get on the car or get on our vehicle and quickly go and ask the local, chai shop wala.
Yeah.
We can go and say that, look, I want to go here, help me. Or we can just stop and ask some guy who is there next to auto wala. But there is a generation which is growing up totally believing a Google Map. And recently you must have heard, there's a news where Google Map took to a bridge which is broken and the car fell down. Now, these are all initial manifestations of the artificial intelligence. Okay. Now this will grow. Now coming back to these bots, chat bots or basic AI bots where you have Cloud AI or Chat GPT or Perplexity, whatever. These are all supposed to be aiding us. Okay, 2 years before, let's say 1 year before, even I used to type things in Google to search. Now I don't do. I use Cloud. Now Cloud is giving me Cloud or Chat GPT, whatever. I'm giving you some names. Now all these AI tools are giving me information. It is also giving me its opinion. Okay, so how do I keep out my bias? How can I separate opinions with raw information?
Mm.
This is where natural intelligence is important. Okay, yes, AI tools will help you. AI tools will make your life easy, but it will never tell you, it can never allow you to judge. So that judgment which is there inbuilt, that comes only with core knowledge. Okay, that core knowledge which we read or we understand, we pick up from the classrooms, from the teacher who is known, is always helpful. Because if at all we start believing some text which comes randomly, eventually one generation may be fine, next generation may be fine, but 3 years down the line, 5 years down the line, the one who is just coming out of class 7th and 8th, they would not understand what it is to read a textbook. Already, I can see many students not picking up a textbook. Okay, a textbook is why the textbooks are important from an academic perspective is that it sort of gives all the knowledge, all the concepts, everything in the form of the author wanted to give. Okay, each author has their own perspective, but what is true is the basic fundamental principles are all taught the way it is supposed to be, and perceptions are changed. When it comes to the AI, what is happening is a chapter 1 concept is linked with chapter 7 concept without going to 2, 3, 4, 5, 6. Okay, which is the answer to it. Let me ask a question. I get a question. I try to get the answer. In that answer, I don't need to go through the concepts which is there in the middle. A student, when he asks the question, when the student asks the question, he or she will get the answer, but they will never get to know why that has come. And eventually, the generation will grow accepting what they get to see from the AI, and they lose their thought making processes, and that is how they eventually lose their decision making process. Now there is a new concept called prompt engineering, saying that it is important to know what you want to prompt. Now that is fine now because you know what to prompt. After a few years, no one knows what to prompt. We simply become a slave of that. So that is the concept. That's something which is scary, and I always feel that every student should make sure that at least go through the traditional way of learning. That way you get the judgment. Okay, now when my PhD students always, when I ask them to give something, they give me some information. And I directly know whether they have asked AI or themselves, because it is very perfect, which is beyond what I expect from that at that stage of the student. There's no wrong in being perfection. But then if it is very perfect, which means they haven't not really gone through the distillation process of knowledge. Okay, so the knowledge distillation comes only when you have the entire principle. So I still feel that yes, AI will be helpful to us, but it's not just utility of it. It is how we use very important. Okay, so let there be a set of people who are developing the tools. That is a different work altogether. But someone who uses it should be able to judge whether it is correct or not, and that judgment will come only if you go through the traditional way of reading. Otherwise, we will be having trouble 10 years down the line.
Absolutely, Santosh. Thanks for that. I think a lot of students and parents especially will find a lot of insights in what you just said. Moving to parents' objections, Santosh, I'm actually skipping some of the questions. We just have 25 minutes more. Most common parent objection, we're actually going back to the BSc question. A physics researcher earns less than a software engineer is one perception or an objection. Is that actually true at the level you operate at? Being a professor, fellow visiting professor at Kyushu University. Can you speak honestly about compensation grants and what a physics career looks financially in India today?
Okay. So how do I achieve it? So this is a very, very difficult question to answer because we are trying to, compare apples and oranges.
Correct.
Okay. It's literally that because uh, when it comes to packages, when it comes to money,
Mm.
different people have different concepts. Okay. So let's keep it very brief, very basic, like what it is typically from a, because let me answer from the point perspective of what any parent who has spent a time lot of time and investment in coaching the kid
Yeah.
to go to a JE exam or a NEET exam. Okay. Feel about it. The point is this. Yes. Every time you have a student getting a placement. Okay. So it's a tangible outcome, right? Placement is a tangible outcome immediately after the education.
Mm.
Okay. So we were taught that end of education is character, but no, it is placement here. Okay. So this placement, when you look at it, the placement, again, it's the prejudice. Point one. Point two is again, it is our yardsticks.
Mm.
So the yardstick which is most common or prevalent is how many lakhs? What is the package?
Yeah.
Okay. So yes, just like how we all say, Sachin Tendulkar is the best player of cricket. Yes, he's the only one in them on so many billions of people around. Okay. So now when it comes to this, yes, every time someone gets a good package, let's say comes out of it, gets in Google or any big company or Meta or anywhere, it gets highlighted. So that sort of inspires people to say that yes, get a good fat salary package,
Mm.
which is true. There is nothing to say no.
Mm.
And from the perspective of parent, yes, they have every right to say that they want to make sure that their child goes into a stream where there is a money at the end of it.
Yeah.
Okay, which is true. Let it be fine.
Mm.
But then, if I want to compare my situation, okay, the way I thought it, so each of us have our own journey. So I will not say that I'm successful, I'm not successful.
Mm.
It's not like that. But if I look at it from the perspective of a student who just graduated,
Mm.
okay, for the placements perspective, yes, you have a placement of X package, which is nice, fat, good to say, distribute the sweets in your mohalla, everything. So that is fine. Okay, that is good. But then, what is the age when the child gets that placement? Maybe around 21, 20, 22. That is the age, right? Fast forward 20 years down the line, when they are in 40 or early 40s, where are they? So this is something which one needs to think from the perspective of that. Okay, the career progression, no one can judge. It is not that you do a PhD or in a physics or you have a beautiful career. There are many examples where careers are not gone as expected. So that is the individual destiny. We cannot say.
Mm.
But from a broader perspective, what I can tell you is that as you grow, okay, a company will give you a job and you end up working in that company and develop whatever is the core mandate of the company, be it services or a product, and you grow in that. And many of the students we know, they go to one place and then skip and go to another one. So they have their own career graph, which they take it.
Yeah.
On the other hand, if I compare to someone traditionally who has come, let's say, let me take a kind of example of us academicians.
Mm.
Okay, that's easy for me to relate.
Yeah.
So as an academician, when I did my PhD, okay, I got very, very small. My income is so small. It's not income, actually, it's a stipend.
Mm.
Okay. So it is different. It is very important to distinguish a stipend to the salary.
Yeah.
Okay. Again, it's again a very, very important point for the student to understand that when you're doing a PhD, you're not really earning. It's a stipend which is helping you to study.
Yeah.
Okay. I think probably not many as you grow. I always feel that after certain stage in life, a student should never ask parents for money.
Mm.
Okay. That they should not be a burden. So I think that is the good thing about as you grow a certain age, you get your stipend, you get your fellowship, and then you try to support yourself.
Mm.
So stipends are meant to support yourself. No, it's not a salary. So because even if the student always compares their stipend to the salary of a guy who joined a company, which is 5 times, 6 times of what people get it.
Yeah.
Presently, if I look at PhD salary stipend, it is 35,000 to 42,000 without HRA. On the other hand, same age when they join a company, it is 1 lakh, 1.2 lakh to starting salary, let's say. And that is about 3 times the cost, the package of what a student gets it,
Yeah.
which is fine. That's a good thing, and they grow. Now, when it comes to the student, clear the PhD, then that is the signboard. There are multiple milestones we talk about it. This is the scoreboard nature, right? So getting a PhD itself is a scoreboard ticked.
Yeah.
Okay, it is not that you just get into PhD. You write an exam, you clear the exams, get the fellowship. Okay, SASR, GATE, these are all not easy exams to clear.
Yeah.
Okay, the same thing with GRE. They have to write exams. So you have to be intellectually good enough to get those things and then get trained. And then as you do PhD, there are multiple, milestones like publications, patents.
Yeah.
All these things are there where you slowly grow in your academically. Okay. Then finally you give the PhD, get the degree, then you get a postdoc. As I said earlier, getting a postdoc is also a difficult thing. You may get, you may not get. But again, postdoc, you get it. It's a postdoc is like some kind of a research associate line, next level. That's again a income option. Okay, let's say you get in MIT or you get in Oxford University, Cambridge University. Wherever you get, whichever place you get, there are certain income states. So you grow up. And then you get a job when you are in 30s.
Yeah.
Let's say a professor, assistant professor. That's a good number. And then after assistant professor, you get an assistant, then professor. So by the time you reach 45, you are a full-fledged professor.
Yeah.
Okay, with a stable income of more than 2 lakhs, approximately. That's the kind of numbers people talk about it. It's all there in the public forum, when it comes to this thing. So that kind of money you get. Apart from that, comparing a situation, it's very personal. Please don't mind those who are into other fields. It is very personal because I keep asking myself, this kind of things happen to us also. When it comes to that, like when I think about myself, okay, I have reached a stage where I have my own lab. I get funds from various funding agencies. So my lab is already a multi-crore facility.
Yeah.
Okay, it's a multi-crore facility, and every labs are like that. So take any IIT, any ISC, whatever, any premier institution labs, they grow beyond crores. Okay, so it is like a company. I'm the CEO of my lab.
Yeah.
I decide, and I run the projects, and my students are products which come out of it, and they do well. They go and they do the next generation work. Yeah. And whatever comes out of it, so I have that kind of academic intellectual freedom. I have that autonomy. I can do whatever I like. Yeah. So these are the things and the respect in the society. Yeah. Okay. And then when it comes to the fellowships, slightly let me diagnose the fellowships. What are these fellowships? Let's say this RSA, the Royal Society of Chemistry. It's a UK-based fellowship. Then we have this Telangana Academy of Science. And then I also have, I'm a member of National Academy of Science. So these are all academies which sort of give you a peer recognition. It is not that you just become a member and get a fellow. It is like there is a distinguished scientist community which sits through, browses through, evaluates you, and then accept you as one of them. Yeah. It's like a peer recognition at the highest level. So these are the things which one may not be able to get if you follow a basic career path. Yeah. So when I talk about placements, now what means a placement is different. It's a different yardstick. So we don't talk about money that way. Yes, we have sufficient money to take care of ourselves and to take care of the family. In addition to that, you have all these new perks, additional perks, which you'll not get if you follow the job market. Yeah. So this is simply to give you a perspective that yes, you have a beautiful future if you get into research. Absolutely. Okay. It's just that thing. So when it comes to the parents, I just want to tell one thing is that, nothing is good, nothing is bad. Okay. Just because you choose one direction, it doesn't mean that will be a perfectly foolproof. There is nothing foolproof. It's the destiny of everybody. Each of us have our own career path and have our own journey. So that we cannot control. But then when it comes to the decision of the student, okay, or the child, make sure that they follow their heart. Yeah. That's enough. If if the student or the kid has this thought that let me go in this direction, they will do well. And it is not just BSc. It can be any form of art. Okay. There should not be any pressure right now. That's what I would like to tell.
Sure, Santosh. A lot of thoughts were actually passing when you were talking about, the IT professionals, to take an example, faces a lot of insecurities. And it's been happening since I think 2011, 2012, when the layoffs actually started in HSBC, and then the layoff season is actually continuing. And And parallel to that is the LLMs which are actually coming in place. So,
Mhm.
what point of going through a CS kind of a degree when LLMs are actually doing a lot of work? So, in this context, and the third context is the fact that the kind of exams, competitive exams that we actually have, whether it's NEET or JEE,
Mhm.
or any kind of exams as such. Even if, for example, say 100 people across India write the exam, top five or top four people actually get the seats that they want, and 90% of the people do not get the university, the IIT or NIT that they actually want to study, right? So in these three kind of perspectives, what's the kind of journey that they can actually take? So pure sciences is one route which they can actually take, and you very beautifully explained in terms of how even the compensation structure is there. But we've got a bulk population. We've got too many students, lakhs of students on an yearly basis going through the same kind of structure on a yearly basis. So any kind of advice from you in terms of what these students can actually pursue once they do not get selected to these particular universities?
Oh, okay. Okay. So yes, this answer is specific to those who want to clear JE or NEET and get into this premier institutions. It's specific to them.
Sure.
There are many who are not into that.
Yeah.
Okay. So they have their own career paths. The point is this: be a good student. Okay. This is something which I learned it in Puttaparthi. I'm very thankful to Swami. Whatever you do, be good in that. So this is a very important message. Okay. Never do take the shortcuts. Whatever you do, try to excel. When it comes to excellence doesn't mean that we are the top, because you can always be top by pushing the other fellow down.
Yeah.
Okay, you can stay where there and pushing the other fellow. You may feel that you are on top, but no, you compete with yourself and you are your own competitor and you try to become better and better and better. So when you keep becoming better, whichever field you go, you will eventually find success. This is the bottom line which I tell my students as well. Okay, become best. Okay, how? This is hard work. There is no shortcut. Okay, so this is a simple general principle I like to tell. Now, when it comes to the opportunity options, which everyone has it. So after 12th, one can take pure science, right? Take a BSc kind of thing. Then there are exams like CUET. You can join Central University, depending upon the marks. Again, the problem is this: our yardstick is always the marks. So you have to be there at the threshold. Always be ready to be the threshold, because unfortunately, everything boils down to what you get in class 10 and what you get in class 12. And the exam you get clear in 3 hours. Now, that is the unfortunate reality, but there is no other way. I feel there is no other option, because our country, specific to our country, we are so much a population that how do you judge? So there must be some way a small gate has to be opened, and this is the gate. You have to go through that, the exam. Okay. So when it comes to the exam, a lot of new exams are there and there are options are there. Because you get into, let's say, integrated MSc. Okay. IITs and NITs, Central University Systems, have this kind of BSMS program, which is not science specific. And there are a lot of options in defense. You can do teaching. Okay. You can get into BSB. These are
Santosh, I've lost you.
I think I lost you. So can you please tell me from till where you learned? Where was the last? I think I lost you for some.
You're talking about defense.
Yes, yes. So there are a lot of sectors. There are defense sectors, there is government sectors, ISRO is there. So the opportunities are plenty. If you want to get into the science stream, I would like to say that I'm not talking anything about the other streams like commerce and arts. In science, opportunities are plenty. Okay, it's just that our society is somehow looks down upon those who cannot clear these exams. Okay, it's just that it's the pressure we put on ourselves. It's the pressure which parents put on themselves, on their kids. Okay, so my advice to anybody is that look, there are a lot of opportunities, and yes, those who can clear the exams and get into any IIT or NIT are very small fraction. Even in NIT and IIT, it's just that a brand, right? Eventually, they have to go and they have to study well and get it,
Yes.
right? Even in NITs and IITs, not everyone can get into computer science. Okay, so there are other streams. So when you are an engineer, become a good engineer. It need not be. This also is true for those who get into local colleges, local engineering colleges, private engineering colleges. Whatever you do, excel. If you cannot excel, no matter where you are, being an IIT or any, it doesn't matter, right? If getting into IIT, getting into IIC, or getting into TIFR is the end of education, then everyone who graduated from IIT or TIFR or IIC should have been doing very well, right? Right. So in that case, someone like me who have no association with any IITs would not get this job.
Yeah.
Okay. So this is what is the important. So we try to become good. Use the opportunities. Opportunities will come. When the opportunity comes, are we ready to take it? So it's the point which you have to keep answering. Be ready for it and keep upskilling ourselves. And upskilling changes with time. Okay. Few years back, if you know C is sufficient, now you have to got to know Python and other things. So what comes under upskilling is very different. Now there is a lot of nano degrees which people talk about it, which many of the universities are giving. You just need to get those certificates, small certificates, which are good enough for you to get a job.
Yeah.
Okay, so one can be aware of this kind of nano degrees. There are MOOCs, massive open online courses. Take it up. Okay, just don't waste the time. Make your journey from age of 15 to age of 25 very, very careful. That 10 years will decide your entire life after that.
Sure.
And whatever you can achieve by 30, that would be the direction where more or less you are there. You may become better depending upon your luck, but try to become something by 25 and improve yourself by 30. This is the thing which I would like to say. So whatever options you get, just move forward. Don't waste. Just keep going forward. Keep going forward.
Sure, Santosh. So two final questions, and I'll see whether we can fit in one more. Typically we're looking at parents listening to the podcast, still unsure whether to support their child's physics dream. Can you give them, say, one company name or one job title or one salary figure, something they can Google tonight that would change their mind? That's question one. And for the students who are listening to the podcast, a 17-year-old who loves physics but is afraid of saying so at the dinner table, what's the first step they should take this Monday?
Okay. Let me maybe I just take a second. So why physics is important is that one should understand many of the discoveries, many of the inventions, many of the technologies which we are using now are somehow originated from someone with a physics degree. Simplest example is our World Wide Web. Okay, there is a physics graduate called Tim Berners-Lee. I think he's from Oxford. He's from London, Queen's College, London. Now he is the one who worked in CERN, and they realized that there needs to be some platform for information sharing, and that is how the World Wide Web started. So it is important that am I lost still? Oh, you're there.
Yeah, I think past 10 seconds. Now it is clear.
It is clear. Okay. So physics as such gives you a lot of opportunities. Now you mentioned about can I Google something and see it? It is very difficult to say which, because majority of the right now, if I look at the overall industry perspective, Indian perspective, our requirement of technology perspective, Indian government has come up with Indian semiconductor mission. There's this national quantum mission. There's a lot of requirement of people who understands the subject. Okay, Indian semiconductor mission but the first one was 76,000. Now this year budget there was 1,000 crore of budget, and national quantum mission which started last year had 6,000 crore budget. Now these are the things which are requiring the ecosystem to make ourselves, our country, Atmanirbhar and Viksit Bharat, whatever you talk about it. We are a country with our service. We are known as service providers. But if you want to bring ourselves to a technology giants, we got to bridge that gap. And I think now I'm being a physicist myself. I feel that we physicists have the know-how and the fundamental understanding to bridge that gap. And Next 5 years is very crucial. Next 5 to 10 years is very crucial for the country to have people who are trained and who can understand and who can become leader. So the next leaders required to have this kind of very deep rooted knowledge, which comes from the fundamental science understanding. Okay, so yes, there is a requirement of engineers, no problem, no point. But I'm not contesting that aspect. But when it comes to the pure sciences, let's say physics in particular, there is a requirement of strong physicists for the country to be able to contribute to the various missions which are going on. And I'm talking about really big budget ones, which would take the country forward. So next 10 years, there would be jobs, a lot of jobs. Okay. As again, make sure that you are able to excel and go further. And for a 17-year-old kid, which who wants to look into the physics, yes, never feel that physics is difficult. Physics is not difficult. You have to see physics everywhere. That is clear that you start liking it. Physics is not solving problems, which is what is told, because for the exams, physics is all about solving the problems. Okay, that is only one can give you a question paper, right? In questions, you have to get, you cannot write descriptive answers. From a fundamental examination point of view, a numerical is easy to give your 4 options to pick up one or two. So that's how the education, the exam pattern have started, but doesn't mean that physics is all about the solving. So make sure that you like this subject, and this subject you can pursue. Let's say you clear, if you want to become an IIT, join IIT, no problem. You can join IIT. And then there are options like engineering physics. We can do it, BTech. There are ICERs, which are offering BSMS program. There are Central University, which is offering integrated MSc program. And there are a lot of opportunities for you to pick. But the point is this, never think that taking science or BSc is a compromise. Okay, because that's how society is telling us right now. That thought should change. Okay, it is your choice. Degree is your choice. What you want to become undergraduate, your UG undergraduate is your choice. You can be a BTech, you can be a BSc, no issue. Being a BSc doesn't mean that you're a bad student. Okay, there are n number of examples who have done excellent. Okay, yeah. So I would say stick to your interest, but excel. Yeah.
Now, I've got 2 minutes for one question I want to ask.
Yeah.
Now, your group actually works at the intersection of physics and engineering, Santosh. So, ultra-fast career dynamics, device fabrication, scintillator-based detection. Is the line between physics and engineering actually as sharp as Indian parents think it is, or are the best opportunities precisely where that line blurs?
The line is blurred long back. In fact, there was never a line. Okay, it is just the line which we draw. That's all. So it's just the line which we draw, because science and technology has always been together. Okay, if you look at many years back, I come from Milan, where Leonardo da Vinci's legacy is there. And if you look at, there is a museum meant for him, and there's so much. The same person has contributed to their underground railways, to multiple technologies which have done that time. So that, in this perspective, I would like to also inform you that I had 1.5 years stint with our IIT Technology Research Park, TRP, it's called, where idea is to bridge industry and academia. We see that there is a lot of requirement which industry has to get from the academia. It's just that the time frames are different. Industry has very quick requirement, academia moves slowly. So from the technology perspective, academia typically moves slowly, because the intention is only to understand and go slowly. What is the eventual outcome? I think in academia, most of the thoughts goes towards developing the home manpower, trying to upskill, train the student to be ready for the next level, where the industry is looking for a product-based kind of thing. Okay, so 5 years, a student finishes 5 years of the work, working in a very applied kind of direction, they are ready to do any industry. And they're much more ready than anyone who's trained in industry, because someone who has joined industry immediately after some engineering, they know that kind of work. But someone who is well trained in all the basics, spent about 10 years reading everything, and eventually focusing on one direction, be it making photodetector, simple things, making a solar cell, they know many things, and the final thesis is on this field. So this guy can adapt much easily anywhere else. So that adaptability is much simpler and easier for someone who goes through this grind. So I would say get this grind done. And yes, that's the point which is very important, where there is no line, there is no blur. In fact, I would say that there is no blur between physics, chemistry, biology also. It's science, technology, and eventually, if we want to develop as a country, we got to think from a product point of view, make our own things. And if you ask me what I would have loved as a child, as a 20-year-old kid, is that I would have loved to pay more attention in making things by myself. Okay. So that one thing which our education should also concentrate on, trying to teach kids to make their own setups, build their own things, simple things. That building is something which is missing. So if you can bring that aspect to us, then it is much more suitable, because that way they're much more ready here, much more ready than to accept the various challenges that comes. Yeah.
Absolutely. I think lovely podcast. I think almost 1 hour now. A quick summary. I think you actually took the viewers through, the origin story, where I think you actually started by sharing the story of how you chose physics. We had a couple of questions over there. And then we look at the real work, the ultra fast light, perovskites, and the next gen tech, couple of questions around UND. You address parents' objections, and you address actually head on in terms of how the research will be, how the career path will be for a physics student as such. Also, actionable steps for students and parents. Very clearly described the route in terms of BSc, MSc, the PhD pathway. I think you named a lot of places like ISSER, IIC, Art Institute, Sathya Institute of High Learning, University of Hyderabad, etc. I think parents would definitely love this podcast, and especially the students, because a lot of insights, practical insights, someone with so much of deep experience sharing. And I think the last question was very interesting, the intersection of physics and engineering. Santosh, so thanks a lot for the insights. I really would love to bring you back maybe in sometime later on with a lot of questions.
Sure.
Also, let me know maybe once the podcast is done if any exciting topics interest you, so that we can actually talk.
Sure. I think there must be another set of things for quantum, because quantum mission is very important for the communications and various defense related issues.
Sure.
Quantum is very, very important. That's something which the next generation kids should be always careful of picking up the direction. Various aspects of quantum technology. Yes.
Definitely, Santosh. So, any concluding words, concluding advice for parents and students of India, given the scenario?
Yes. First of all, thank you, Ravikant, for this wonderful opportunity to have a prevailing chat, whatever it is. So, with you regarding this field, because this aspect of what if my kid doesn't clear JE or NEET has been really, really a troubling point. It's stressing out parents, it's stressing out kids. Okay. So that should be addressed, saying that anything is okay. Okay. Anything is okay as long as the student does well. Point one. Point two. Whatever we do, we should try to become best. And opportunities are there, opportunities will come, and no one will be left poor. There is a lot of money everywhere. It's just that are we skilled enough? Are we ready to grab that opportunity? That opportunity will come only if you are skilled. So upskill yourself every point of time. Just that doesn't mean you get a job, you get a seat in IIT or good enough. No. Being in IIT is also just a starting point, right? You just have different starting points. Okay. So this starting point is only different being in IIT or NIT or let's say AIMS or wherever. Point is this: once you get what you are after that, you're as good as today, not yesterday. Your tomorrow is today's, what you do today. So make sure that we always plan for tomorrow, which means make sure that we are, whatever we are doing, whatever is best for today. So for that, please upskill yourself, learn as much as possible, keep your eyes open with growing technologies, growing necessity of technology, which direction it is there. Right now, it is semiconductor mission, quantum mission. Okay, this will change. Okay, so we always in our lab, which I keep telling my students that look, skills are important, materials will change. Okay, right now, perovskites and transition metal TMDC are very, very exotic, but we never know what happens after that. Okay, once you explore this, you should go. But then the techniques which is there to understand the fundamental principles are always the same. And these techniques have been there from the beginning. Okay, and for those who think quantum mechanics is very abstract, very fact that you can turn on your bulb, you can turn on your LED, your laser, your mobile, it's all quantum mechanics in action. Okay, so these are the manifestation of quantum mechanics. So, laser is a direct quantum device. Clear? So it's physics everywhere. You can see physics everywhere. So just stay bindas, be happy, and do well in your life. Thanks for the opportunity.
Perfect, Santosh. Thanks so much for your time. And I think I'll catch you again with another topic. I think quantum mechanics is already something which you suggested. So we'll give some time and I'll pull you back again, Santosh. Thanks so much, and I'll be in touch.
Sure. Thank you. Thanks for the time.